Today we're going to focus on new stuff where we're going to talk about magnetic field. Now, this magnetic field is very important, guys, because magnetic field is where we learn how we generate current. Like you guys have your iPad, have your iPhone, have your MacBook, all run by electricity. Your aircon, your light bulb, all run by electricity. But where do we get electricity from? So this is what we're going to learn for this chapter, okay? So the electricity that is produced is due to magnetic field. Of course, before going into production of current, we need to learn the basic of magnetic field first. What is a magnetic field? What is a magnet? Okay, so when we talk about what is magnet, right, guys? Have you guys seen a magnet before? Yes, right? So magnet, I think most common one that you guys seen is a fridge magnet, right? The one that attached to your fridge one. But if you guys try using the fridge magnet to attach onto other metal, such as your window frame, if you attach to your window frame, the magnet will not be stick. It will not stay there. The magnet will fall. Have you guys tried that before? Not all metals magnet can be attracted to. Only certain metal can. Not all. So just now we mentioned, not all the metals they can turn into magnet. All right. So we must have a special name for those metal can turn into a magnet. So those special name, we call them as a ferrous metal. Later I'll write it for you guys. I'm not sharing the screen yet. So ferrous metal is the metal that can become a magnet or it can be attracted by a magnet. That metal we call a ferrous metal. A very, very common example, iron. All right. That's why your door frame is usually made up of iron. But if your main gate normally made up of aluminium, steel gate or whatever lah. If it's steel or iron, it can be attracted to. But if it's aluminium, magnesium, nickel, copper, all these cannot attracted by magnet. Meaning to say that you take a magnet, you got close to those copper, magnesium, this thing won't be attracted to the magnet. Because not all metal can become a magnet. Only certain metal. And for your level as an IGCSE student, you just need to know two. The two metal that can become a magnet, iron and steel, the basic one. All other metal other than this cannot be attracted to a magnet. So when they cannot be attracted to a magnet, we call them as non-ferrous metal. Now, just like I mentioned, two types of metal here. What are those? Ferrous metal and non-ferrous metal. Like what are the ferrous metal? Iron and steel. So other than iron and steel, the rest are all non-ferrous metal. Non-ferrous means they cannot turn into magnet or they cannot attracted by a magnet. If you don't believe me, go home, your fridge full of magnets, isn't it? Take one of your fridge magnet, try to look for aluminium frame, especially your window frame. Window frame normally made up of aluminium. Then you can try to stick on it. It cannot stick. Okay, it cannot stick onto aluminium frame. All right, so non-ferrous metal, there's aluminum, there's copper, Cu, magnesium, Mg, nickel, Ni, Pb, lead, zinc, Zn, tin, Sn. All right, so these are the metals that can turn into magnet. So now, since we have two metals that can be a magnet, right? Iron and steel. So what is the difference between them? Guys, basic knowledge, iron and steel, which one is stronger? Steel much more stronger, correct or not? That's why your door, your frame, your whatever thing that's for security purpose is made up of steel. Am I right? It's not made of iron. Iron, in terms of chemistry, they are very soft metal, easy to malleable, easy to change the shapes. Iron, a soft metal. Steel is a very hard metal. So guys, since iron is soft, if you want to turn iron into a magnet, it will be very, very easy. If you want to reduce the magnetism of iron, it will be very, very easy. Can or not? But for steel, it's very hard. If you want to make it become a magnet, it takes a very long time. But once steel become a magnet, steel forever is a magnet. Unless you go and reduce the magnetism. All right? If you don't leave it, your fridge magnet will stay there forever. Correct or not? Do you ever see your fridge magnet drop itself? No. Unless the fridge magnet is dropped a lot of time, then the magnetism losing, then they cannot stick to the fridge already. But if no other any physical factor, the magnet of your fridge will just stay at the fridge for a long period of time. 10 years, 20 years, 30 years, until you're old, until you got grandchildren, the magnet is still there. Because that magnet made up of steel. Once steel is become magnetized, the steel will be forever magnetized. It stays very, very long period of time. So steel, usually we use it to make a permanent magnet, such as what? A bar magnet, got North Pole and South Pole. A U-shaped magnet, correct or not? All those magnetism is there forever. So those magnets are made up by steel, can or not? Iron, where do we see iron magnet? You don't see commonly one. Normally you see it in the movie, because in real life we don't really use it. I mean, we don't use it, but many people using it. So this temporary magnet is like, oh, you guys watch Mr. Bean or not? And you know Mr. Bean always have a green little car, right? The Mini Cooper, the green Mini Cooper. So that fella always simply park his car one, isn't it? Simply park on the roadside. Then always got people summon, or people who have a big piece of metal come above the car, and then the fella go and switch on, then the car will be attracted to the metal, and then this metal, and then release the car to a rubbish place or whatever correct or not? So that piece of metal, why would it attract the car? Because car made up mainly by steel and iron, am I right? So car, once this piece of metal, I turn on the current, I already magnetize the metal, so I can attract the car. So I bring this thing over, and now I want to release the car. What I need to do? I need to reduce the magnetism. I turn off the current. Then magnetism is reduced. Then the car will drop. Is that okay? So that piece of metal there, it's a temporary magnet. You want it to become magnet, you turn on current. You want it to lose the magnet, you turn off the current. Correct or not? If it's steel, cannot do that. Because steel, if you magnetize the steel, forever is there. Forever the car stuck with it already. You cannot pull the car down. Get what I mean? So in order to have that, this piece of metal on top, we use iron. Because iron is easily to be magnetized and easily to be demagnetized. Magnetized means turning it to become a magnet. Demagnetized means make it lose its magnetism. Understand or not? Alright, so from here you guys can feel now. So iron can be magnetized and demagnetized easily. So steel usually is meant for permanent magnet lah, because it retains its magnetism for long period of time. Okay, after you guys write down all these like metals, all these like iron and steel, right? So guys, why did I mention iron is a temporary magnet? Because you have to know in exam that you ask why iron is being chosen to be a temporary magnet. Why, Venice? Why do we use iron as a temporary? Why not permanent? Because iron is soft, it's easy to magnetize and demagnetize. You want it, you turn on. You don't want it, you turn off. That's why we choose it as temporary magnet. But what if it's steel? You turn on the current, the steel become a magnet. When you turn off, do you think the magnetism go off? No, steel stay forever. Alright? That's why steel is not suitable for a temporary magnet.